Howdy there, Internet students. It's Mr. Hermanson again. Today we're going to do the second lesson on our quadratics, learning how to multiply a monomial by a polynomial and how to factor a monomial from a polynomial. Okay. For this review, just go ahead and do it yourself, and you can check back and see if you got the right answers. I just talked quickly about these and what makes it a factor. So if there's some way to write the number times something else, so we're wondering if x to the third is a factor. Since we can write this product like this, and we could break that down as 9x times x to the third. Remember, this is x to the first, and you add the powers. Notice that x to the third is a factor, okay? The only one that you can't do that with is the 12x to the second. All right, so the first thing we're going to learn how to do is multiply a monomial and a trinomial. Basically, we're just using the distributive property. So we're going to multiply this x squared times this, the x squared times this, the x squared times this. Now remember, when you're multiplying powers, you add them. Because remember, this is x times x right here, and this is x times x times x. So you really are multiplying by x 5 times. So you get 3x to the fifth minus 2x to the fourth, because you have two factors of x here and then two more there. And then the last term is just 8 times x squared. So that would be, it's not these because it's not x to the sixth, and we need a minus 2x to the fourth. So that would be that one. All right, why don't you try one of those? See if you can get the right answer. Does your answer look something like that? Hopefully it does. Okay, now we're going to reverse the process. What we're going to look for is the greatest common factor of these three terms, and we're going to factor that out. So what we're doing is writing it in what's known as factored form. So let's first talk about the coefficients and see if we can figure out what the greatest common factor of 6, 12, and 18 are. You're probably guessing that it's 6, right? So we're going to put that. We'll put a 6 there. And then we also want to know what is the greatest common factor of x to the third, x squared, and x itself. Well, x to the third is this, x squared is this, and x by itself is this. X is the only thing that they all have in common. So I'm going to put that out here. So 6x is the greatest common factor. And I want to write it as a product of the greatest common factor and then whatever you would multiply. So now you have to think about this. 6x times what makes 6x to the third, this first term? And it seems like the only thing we're missing are two factors of x. So I'm going to put that there. Now 6 times 2 is 12. And then to get x to the second, since we only have x to the first here, we're going to need one more factor of x. And then 6x times 3 is 18x. So let me rewrite that since I have a bunch of scribbles on that. We have 6x times the quantity, x squared plus 2x plus 3. All right, why don't you try one of those? And my answer looks like that. Now, the way you would check that is take your monomial out here multiplied by the first term. So 3x times x to the third, that's 3 times x times x times x times x, or 3x to the fourth, which is that. Good. And 3 times negative 3 is negative 9, and then we have x times x, which is x to the second, which is that. And 3 times 4 is negative 4 is negative 12, but we also have the x, so negative 12x. So yeah, that works. All right. Factoring out a monomial. Basically, we're doing what we just said. We're going to look for the greatest common factor. And I think I did in the last two problems a little more than I needed to. All we had to do was find the greatest common factor, which would have been 6x for that one and 3x for this one. And what I just showed you how to do is what we're going to do here. So why don't I just go ahead and let you see if you can factor it out yourself, and you can check back and see if you got the right answer. Does your answer look something like that? Go ahead and try another one. And on this one, I'm kind of wondering if any of you made the mistake right here when you factored out 3x squared, that you didn't, maybe you thought you multiplied, so you put a 3 here because 2 times 3 is 6, but make sure you check that these two numbers, the 2 and the 4, need to add up to that power because you're counting how many times you're multiplying by 4. All right, so we're going to do a little problem where we're going to write the answer in factored form. So we want to know what is the shaded area. So we're looking for this stuff right here. And it's a square. So to find the area of the square, just multiply the length times the width, which is 3r times 3r, which is 9r squared. Then we're going to subtract the area of the circle, which, if you remember, the formula for a circle is just pi r squared. Okay. Now we're going to factor this, find the greatest common factor. It looks like both of these are multiplied by r squared. So we can put that in the outside. And to get this first term, 9r squared, we need a 9 here, right? Now we have 9r squared. And to get pi r squared, we need to put the pi there. So there you have it in factored form. Why don't you try this one? So here's what my work looks like there. Notice some of you may have missed this, but 36 and 9 have a greatest common factor of 9, so you could factor out the 9 there. Anyway, all right. Looks like that's it. You're ready to try some practice. Go ahead and give that a shot. And once again, if you have any problems that you're not sure about, you're free to message me on those. Talk to you later.